Hi everyone, and welcome to Unit 4, Mod 16. We're talking about basic principles of sensation and perception today. Here are your learning objectives, and here are your vocab. Pause where you need to. So let's start with sensation, since this is sensation and perception unit. Sensation is just the process of our senses taking in sensory information. So taking in sight, touch, taste, smell, hearing, all of those things, and bringing that information to the brain. That is perception is what our brain does with that sensory information. So perception is the interpretation of sensory information. So for example, you see a bottle there, that image, and you look at it and you say, oh, it's hot sauce, right? So you're looking at the image and you can identify and make meaning out of what that color, that particular glass bottle means to you. There are two different types of processing. So bottom-up processing is starting with the senses. Bottom up means taking sensory information and trying to figure out what something means or what something is based on what you are seeing or what you are hearing. So, for example, if you don't know the word in a song, you're really listening to the sound of that thing. You're not taking into account the words before it, the singer, any of your expectations or thoughts. You're just taking in the sound to figure out what that word is. That would be bottom-up processing. Top-down processing is the opposite. So it's taking our expectations, our thoughts, our knowledge, our experience, and trying to interpret sensory information that way. So if we don't know the word in a part of a song, we fill it in by what we expect based on the words before it, or based on what we know about the singer and what word they might choose for that part. So we fill it in with our expectations or what our brain is telling us. So brain is top, bottom is... So some people have what is called prosopagnosia, and this is also known as face blindness. So there is a particular part of our brain in the right hemisphere that is for identifying and recognizing faces. So people with face blindness, that part of their brain does not work the same as the rest of us. So they cannot accurately identify a family member, their child, a coworker. They can't even accurately identify their selective attention. So we're going to talk a lot about attention today. So this is just the focusing of our conscious awareness on a particular stimulus. And in talking about this, there is something called the cocktail party effect. So this is, let's say you're at a party and you're having a conversation with someone, and all of a sudden you hear your name in another conversation. Not even right next to you, maybe like a couple of people away, and you hear your name, and it's not being yelled or anything, but you realize once you've heard your name that you can also kind of go back a little bit in the conversation, and you actually heard more of it than you were aware of. So this ability to detect our own name, even though we weren't paying attention to that conversation, that is known as the cocktail party effect. And it also kind of shows you that dual processing brain that we've talked about before, that there is information that our brain is processing that we are not aware of. All right, selective attention and accidents. We know that all of these electronic gadgets, it could be your phone, it could be the GPS in your car, it could be changing radio stations, or just even talking hands-free. All of those increase your risk of having an accident. They actually have found that passengers in the car create much less of a risk of accident than hands-free phone. And the reason is because, or one reason why they think, we don't know for sure, is because the passengers in the car are very aware of when the traffic gets confusing or you're navigating a difficult part of the road and the conversation naturally dies down. So they think that might be why that happens. So inattentional blindness also has to do with our selective inattention. So this is when something was there or happening and we are not aware of it because we were not paying attention to it. So magicians use this a lot. They direct our attention to one place so that they can do other things without our noticing. Another form of our inattention is change blindness. So this is failing to notice a change in the environment. So something was one way and now it's another. So a item in the background changed from being a picture of the ocean to a picture of the forest. So it's usually something like background or something that's like not super important. And that there is also something known as choice blindness. This is where people make a selection, they make a preference. So which photo is more attractive, right? And they're very similar photos. Person picks one picture and then asked again later, they pick a different person, believing that's, and just be careful with change blindness and inattention. So inattentional blindness is the thing was always there, you just weren't noticing it, but change blindness, something was one way and it changed to something. Transduction. So transduction is just the process of taking that physical stimulus energy, such as a light wave, and taking that and turning it into a neural impulse so that our brain can interpret it. So if you look at the picture of the butterfly, taking the light waves that are bouncing off the butterfly's wings that go through our retina, becomes a neural impulse and sends that information to the brain. That process is called transduction. And psychophysics, they study the relationship between the physical characteristic of the stimuli and our experience of that. So our psychological experience. So for example, when you look at the railroad tracks down below, if you're looking at them, it looks like the lines converge and the railroad tracks come to like a point. But we don't tend to perceive that, right? We perceive that those railroad tracks keep going really far away. They're not absolute threshold. So this is the minimum amount of stimulation needed in order to detect any sort of stimuli, light, sound, odor, etc. So let's take the candle flame from 30 miles away. You could detect a candle flame 30 miles away on a clear night, which is the statistic that they've found. That has met your absolute threshold. If you can't detect the candle flame 30.5 miles away, then it has not met your absolute threshold. So as soon as you can become consciously aware of a sensation, it has crossed your absolute threshold. So in science, we like operational definitions. We like to define our variables. So what does that mean? If I can detect a candle flame 30 miles away on a really good night, and it's one night and then I can never again, is that actually my absolute threshold? So they say it has to occur in 50% of the times it's tested. So if you were to do this experiment with the candle flame 100 times, you would have to detect the candle flame 50 of those 100 times for it to cross absolute. Signal detection theory, this is also related to noticing things. So this predicts how and when we detect the presence of a stimulus amid background noise. So for example, a new mother who thinks that they hear their newborn crying, right? They're probably more likely to hear that signal or that sound amongst other background noise. Maybe they have people over and there's conversation, and the other people in the room don't notice the baby's crying sound, but the new mother does. So that idea that our expectations, our personal experiences, our personal motivations, they affect what we are able to detect for signals. That is signal detection. Priming our brain. So this is an often unconscious, but not always, activation of certain associations, and it predisposes us to a certain response or a certain thought. So if you look at the example here, it says fill in the missing word, and it gives you red, blue, orange, yellow, and then GR. So what would that be? And then if you look at the next column, it says fill in the missing word again, plum, nectarine, pear, apple, and then GR. So probably for the first one, you said green, right? And for the second one, you said grapes, or grape technically, because there's no spot for S. So that is priming. You said, oh, there's a bunch of colors, so something that starts with GR that's a color, okay, green. Now there's a bunch of fruit, filling in GR that's a fruit, okay, that's a grape. So priming is getting your brain thinking a certain way to give a particular difference. Thresholds are noticing a difference between two stimuli. And this is also known as just noticeable difference. So if you look at the light bulbs up at the top, you might not be able to notice a difference between the first one that says no and the second one that says no. So that means it has not met your difference threshold. If you can look at the first one that says no and then the one that says yes and notice a difference, then that is where it has met your difference threshold. And just like absolute threshold, it has to do this 50% of the time. There is also something known as Weber's law, and this is the difference between two stimuli, so difference threshold. Your difference threshold must differ by a constant minimum percentage. So, for example, if I have two weights, I have a 2-pound weight and a 5-pound weight. Those are fairly light weights, and I'm going to be able to notice the difference between a 2-pound weight and a 5-pound weight. However, so that's a difference of 3 pounds, right? If you put a 100-pound weight in this hand and a 103-pound weight in this hand, you are probably not going to be able to tell a difference. And that's because that 3 pounds, it's so heavy. There's so much stimulus, you can't notice the difference. So in order to notice the difference, I might have to go 100 to 110 or 15. And as soon as I can notice that difference, then it's met difference threshold. But the more of a stimulus, the more difference is needed. So think of sound. The difference between 2 on your radio and 5, you can probably notice that. But the difference between 60 and 63, you probably can't notice. You need something like 60 and maybe 70 to notice a difference. So that is Weber's law. Sensory adaptation is the diminished sensitivity as a consequence of constant stimulation, right? You walk into the science lab and there's been some sort of lab going on and it smells. And after a while, you forget that it smells that way until the next class comes in and says, oh, it smells so bad in here. That is sensory adaptation. Okay, so take in millions of little bits of information per second, but we can really only consciously and effortlessly attend to one thing at a time. So when we are multitasking, we're just switching back and forth between different stimuli and giving them our attention. Inattentional blindness, our brains miss tiny changes or choices. We're slightly off if they're little and not super important and big differences. And finally, we do not see the world as it is. We see the world as it is useful for us to perceive it. Okay, so that wraps up Module 16.